we have a halo catalog, which we'll first start looking at, and we have to find a way to match or find a relation between uh, the galaxy luminosity and the halo mass. Okay. So so what we are going to do is, as I said earlier, uh, the most massive galaxies, we will assume that they reside in the most massive halos. And in general, if I were to, if I was able to get observations of halo masses and separately observations of galaxy luminosities which I have, then I would find that there should be a scatter in the relation. Okay, they should be correlated, but there should still be some scatter. So what we will assume here is that there is actually no scatter, and this is something which can be, so whatever we are going to present is can be further extended to include scatter between the relation of the halo mass and the galaxy luminosity. So what I've plotted here is forget the H1. Okay, you think of it as a galaxy luminosity function, which is the cumulant. So anything more luminous than a certain value is basically I've done it by integrating uh, from a certain value to the to infinity, and I plot n greater than mr. Okay, so H1 you should read as mr. And I have the Schechter function. I have the cumulant of the Schechter function, which looks like this. Okay. And again, for MR, this will be swapped in axis because MR is negative, but you can think of it as this as minus MR, okay, in some units. Similarly, I do the same thing for the halo mass function, and I find this is the number density of objects with masses greater than some value, which is the value in the x-axis. Okay. Now, if I assume that every object is in a given halo, okay, or is associated with a given halo, and the relation between these two properties, that is the halo mass and the luminosity, is on average a monotonic relation, then I can relate these two relations, okay, even though I do not separately have observations of halos, I can relate these two relations by abundance matching. So what do? I say that I start from the highest or the most luminous object, go down to the faintest object. And similarly, I will say that if I have one object here, okay, and one object here, the relation between the R band magnitude here is equal to the R band the halo mass here. Okay, so I match abundances. So I take a particular value, I will read off its intersection with the cumulant, and that is the current R band magnitude. And the same intersection I will read off in the halo mass, and that will be the associated halo mass. So based on these two distribution functions, I am able to now generate or associate luminosities to halos, which is a galaxy property. Okay. So before the last session, we said how to generate a Schechter function. Okay. So you can work this way, or you can take an analytical Schechter function. Okay. And get me work with an analytical mass function and get the relation between R band magnitude and halo mass, or you can mix it up, take a tabulated value or analytical value or tabulated value, etc. And similarly read off this relation between MR and halo mass. So in what follows, what we have done till now, to summarize, we have a tabulated value of the H1, MR R band magnitude. We have fitted a Schechter function to that, and we'll use that as an analytical value, analytical form of the Schechter function. We'll integrate that, and then we'll work with the halo catalog. We'll bind them to get a halo mass function, and then we will do an interpolation between, or an identification by matching this R band magnitude to this halo mass. Okay, so don't worry about too much about the numbers here. Okay, if you think of this just as any other galaxy property, It can be a velocity function also. So similarly, you can work with in the same manner. You can go about identifying or assigning galaxy properties to halos. So this is the basic idea. Okay. So now that I have said that, let's quickly again we'll keep our instructions